Okay, geometry. Can you believe we are in chapter 7? And in section 1, we are talking about ratios in similar polygons. So pause the video, attempt these questions, come back and check your work. Good. And if triangle QRS is congruent to triangle ZYX, identify the pairs of congruent angles and the pairs of congruent sides. So the angles would be angle Q with angle Z, right? Angle R with angle Y, angle S, angle X, and then we have QR with ZY, and segment RS with YX, and finally segment QS with ZX. Good. And you should have found X equals 9, and don't forget to distribute, right? And in this case, X equals 18. Today's objectives include identifying similar polygons and applying properties of similar polygons to solve problems. Our vocab includes similar polygons, and similarity ratio. So hopefully you are already feeling it, feeling like you understand similar. We've worked with these things before. So here we have two figures that are similar. Figures that are similar, and we use a single wavy line rather than two wavy lines. When we have two, what did we say? That's right, congruent. Similar has only one. Similar figures have the same shape, but not necessarily the same size. So here we have figure 1 and figure 2 are similar. Same shape, not same size. Figure 1 and figure 3, not same shape, not similar. So our definition of similar polygons: two polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So notice that angle A and E are both right angles, congruent, right? Angle D and H are also right angles, congruent. Angle B is congruent to angle F, and finally angle C is congruent to angle G. We see that side AD is down here is proportional to side EH, 5/10, which equals 1/2, right? Just as side AB is proportional to side EF, 6/12, which also is 1/2, and so on, right? So when we have similar polygons, the sides are proportional and the angles are all congruent. So identify the pairs of congruent angles and corresponding sides in these similar polygons. And one thing you could do, right, is set up the similarity statement by finding corresponding angles, right? So in other words, angle N is congruent to angle Q, right? And angle P is congruent to angle R. And so we could name this NPM if we named this QRT. They are congruent or similar in that way. So we can say that these angles are congruent. And so by third angle theorem, we know that angle M must be congruent to angle T, right? So now we can say side MP is is proportional to side RT or TR, right? Just as we can say that side MN, which is 2, is proportional to side TQ, which is 1. And 2/1 is also 2, right? And finally, we can name the last sides. NP, again, from the larger triangle, is proportional to QR from the smaller one, and we have the same ratio of 2. This ratio we found is known as the similarity ratio. It is the ratio of the lengths of the corresponding sides of two similar polygons. So the similarity ratio of triangle ABC to triangle DEF is 3 to 6, right? Or 1/2. We could also name a similarity ratio of this triangle DEF to triangle ABC. It would be 6 to 3, or a ratio of 2. So as we've said before, when you write a similarity statement, it is like writing a congruency statement. Be sure to list corresponding vertices in the same order. So let's determine whether the polygons we see here are similar. If so, write the similarity ratio and a similarity statement. So first, they didn't give us this information, but if we are told that these rectangles, that these are rectangles, then we know that each of the angles are 90, right? And so let's say that we're told that they're rectangles. So now we know they have corresponding angles that are congruent. So we need to see if they have a similarity ratio, and we can do that by testing the known sides, right? So we could say that AB is 6, right? 6 to 4 from FE. Is that equal to 9 to 6? So is 6 over 4 equal to 9 over 6? And 6 over 4 is 3 halves, right? And 9 over 6 is 3 halves. So yes, the rectangles are similar. We can say that ABCD is similar to EFGH, which is basically what we're told here, with a similarity ratio of 3 over 2. These rectangles are similar. When you work with proportions, be sure the ratios compare corresponding measures. A mistake would be to compare sides that are not really corresponding sides, right? So be sure that they are corresponding sides. Let's try this hobby application. Find the length of the model to the nearest tenth of a centimeter. So this is like in pre-algebra when we were using scale, right? So if we know that this is a scale model, then we are given this much information, we can set up a proportion, can't we? We know that it can be set up, gosh, in 8 ways, but we know that X is the length of the model, right, in centimeters. And the rectangular model of the racing car is similar to the rectangular actual racing car, right? So the corresponding lengths are proportional. So we could say X over 5 should equal 6.3 over 1.8. We could also flip that proportion completely to its reciprocal. We could say 5 over X should equal 1.8 over 6.3. So let's see what the key decides to do. The key decides to put the actual over the model. So let's see how we substitute those values. The actual length of the car was 5 meters, right, over the length of the model, which we're saying is X. Notice we have different units here, right? So that should equal 1.8, which is the width of the racing car in meters, over 6.3 centimeters. And now we simply solve, and we should get our answer here, right? Cross products property, and we should have 17.5 X. X is 17.5, or 17.5 centimeters is the length of the model. Boxcar has the dimensions shown. A model of a boxcar, like the one I have in class, my little Z gauge, right, is given. So find the length of the model to the nearest inch. Please pause the video and come back and check out the key. So we again have the length of the actual boxcar over the model should equal the width of the actual boxcar over the width of the model. So we can substitute, and now we can use our cross products property to solve, right? And when we do, you should have the length of the model is approximately 5 inches, almost 5 inches, actually a little more, just a hair more, right? Okay, so please, I know you're in a race to get to your assignment, but please do take a moment and answer these questions. They shouldn't take you too long. come back and check your work. Do it carefully. This is not a race. Your answer for number 1, similarity ratio and a similarity statement cannot be made because these are not similar. Okay. How about number 2? What is the length of the actual sailboat in feet? 25 feet. And again, pause, come back and check your answer. Are 2 equilateral triangles similar? Always, sometimes, or never? Equilateral means they are equiangular, right? So 2 equilateral are always similar. And there you go. Good job. Have a fun time.